Hello everyone. Welcome back to my channel. Today, we are diving deep into the world of random forests, a powerful machine learning algorithm used for data analysis. Whether you're a beginner or an experienced data analyst, this tutorial will guide you through everything you need to know about using random forests effectively. Before we get started, let's outline what we'll cover in this tutorial. We will discuss the concept of random forests, explore how to implement this algorithm using Java, and walk through a hands-on example using a popular dataset. So, what exactly is a random forest? Essentially, it's an ensemble learning method that operates by constructing a multitude of decision trees at training time. The output can be the class, that is the mode of the class's output by individual trees for classification, or the mean prediction of the individual trees for regression. Now, let's take a look at the core principles behind random forests. The algorithm takes a random sample of the dataset and builds a decision tree, then aggregates the results from multiple decision trees to improve accuracy and control overfitting. Here's an outline of how random forests work. 1. Randomly select a subset of your training data. 2. Build a decision tree from that subset. 3. Repeat the process for a specified number of trees. 4. For regression, average the results, and for classification, take a majority vote. Let's get our hands dirty with some code. First, ensure you have the required libraries in your Java project. For working with random forests, the Weka library is a great choice. You can download it from the official Weka website or include it as a Maven dependency. With that set up, let's move on to the code. First, we need to import the necessary classes from the Weka library. Next, we will create a method to load our dataset. For this tutorial, let's use the famous Iris dataset that comes with Weka for simplicity. This dataset is great for classification tasks. Now, we need to ensure that our target class attribute is set correctly. In the case of the Iris dataset, the class attribute is the species of the flower. Next, let's create a method that will train our random forest model using the loaded dataset. We will also add parameters to fine-tune our model if desired. Once we have trained the model, we can make predictions. Let's create a method for that as well. We'll accept an instance of data that we want to classify. Finally, let's put everything together in our main method. We will load the dataset, train our random forest model, and make predictions for some sample instances. Now that we have our complete code ready, let's run the program and see our random forest in action. This will give us the predicted classes for our samples in the Iris dataset. As we run the code, you should see the predicted classes printed out for each instance in the dataset. The accuracy of our random forest model will depend on various factors, including the parameters we set and the data itself. Now, while we are able to predict classes, it's crucial to evaluate our model's performance. We'll introduce a cross-validation approach to do this. In Weka, we can achieve cross-validation with the help of the evaluation class. Next, let's integrate the evaluation method into our main function to see how our model performs. As we integrate the evaluation and rerun the program, our console will output a summary including accuracy, precision, and recall metrics for the random forest model. This is vital in understanding how well our model is performing. Now let's talk a bit about hyperparameter tuning with random forests. Various parameters such as the number of trees, maximum depth of the trees, and minimum instances per leaf can drastically affect the results. We'll demonstrate how to adjust these in our implementation. We can add these settings to our train random forest method before building the classifier. Adjusting these parameters can lead to better model performance, especially in complex datasets. Finally, let's reflect on the concept of feature importance. One of the significant advantages of random forests is their ability to gauge the importance of different features in making predictions. Weka provides a way to extract this information. We can add this snippet to our main method after we've trained our model to see which features contributed most to our predictions. It will help in understanding the dataset and informing feature selection in future models. So, here we are. You've successfully learned how to implement random forests for data analysis in Java. We covered the core principles: setup, training, prediction, evaluation, hyperparameter tuning, and feature importance. Random forests can be a game changer in turning your datasets into actionable insights. Thank you for joining me in this extensive tutorial. If you found this video helpful, please give it a thumbs up And don't forget to subscribe for more programming tutorials. If you have any questions, feel free to leave them in the comments below. Happy coding!